In this video, we'll have a quick look at solving equations using the balance method. When solving equations using the balance method, there are three really important things that we have to keep in mind, and if we stick to them every time, we should be right. The first one is, when we're solving equations, the aim really is just to get the unknown number by itself. The unknown number in any equation is just a letter that represents a number that we don't know about. So it could be x in most cases, because that's generally a popular one. It could be z, it could be q, it could be m, it could be anything. The next thing that we need to keep in mind is when we're doing things to get x, or to get the unknown number by itself, we need to make sure that whatever we do to one side, we always do to the other. Because the whole point of a true equation is that they're balanced. If we do something to one side and not the other, then all of a sudden those two sides of the equal sign no longer have the same value. And lastly, it's really important that you show all of your working out, because this helps you pick up on your own mistakes if anything goes wrong. It also proves to your teacher that you know what you're doing and you're not just writing an answer down. So remembering these three simple little tips, hopefully that'll make our job a lot easier. So let's get straight into it. So our first example is 4x minus 1 equals 31. So remembering that first tip, the aim is to get the unknown number by itself. Well, in this case, the unknown number is just this x here. So we want that one to be on its own with nothing next to it, or on top of it, or below it. And to do that, we need to somehow get rid of this 1 here and get rid of the 4 there. And it's really important that we do them in the right order, because if we do them in the wrong order, then we won't get the right answer. What I like to do to help myself sometimes is I draw myself a little table that can help me remember what to do first. So if I was building this equation, or if I knew what x was, the very first thing that I would do to x would be to times it by 4. After that, I would minus 1, and that would end up giving me 31, hopefully. So that's if I was building the equation or working it out. If I want to solve it, what I'm going to do is do the opposite operations in the reverse order. So I'll start by adding 1, because that's the opposite operation, or the inverse of minusing 1. And then the opposite of timesing by 4 is divide, so I'll divide by 4. So when we're solving, it's pretty much BODMAS in reverse. So we're going to add 1 to both sides first, and then divide both sides by 4. And hopefully that will get x by itself and give us a nice number on the other side. So let's get started. What I like to do when I'm showing all my working out is I like to do my operations, or what I'm doing, in a different colour, just to make it clear to me and everyone else reading my working out. So the first step was to add 1 to both sides. So I'm going to, just above, really small, do a plus 1 to both sides of the equation. So if I add 1 to this side here, what happens is this minus 1 disappears, because if I'm minusing 1 and then adding it back again, well, they're just undoing each other. So the left-hand side of the equation will look like this. It will just have 4x by itself. Then if we add 1 to 31, that gives us 32. So we've done this one, we've dealt with that. The next step was to divide by 4. So again, keeping that second rule in mind, always do the same to both sides. I'm going to divide both sides by 4. So on the left-hand side of the equation, what will happen is, because this is a little imaginary times in between there, that's 4 times x. If I'm multiplying by x and then dividing it again, I'm really just undoing each other. So I'll just end up with x by itself on this side. On the right-hand side, 32 divided by 4 gives me 8. So now that x is by itself, I can see that because both sides have the same value, x must be 8. Now, I can check this by, maybe I'll get a different colour. I think I like green. I can check this by getting the value for x and sticking it back in the original equation. So let's quickly do that. So 4 times, instead of x, I'll put 8 minus 1. Hopefully that gives us 31. Let's see. Well, 4 times 8, that gives us 32. We still need to minus 1. And then if I go 32 minus 1, I've run out of room, but that will definitely give us, maybe I'll do a bit of an arrow. Yeah, and 31 definitely equals 31, so we're all good. So our next example is 2x, or 2 times x. So 2x divided by 6 equals 4. So in this case, the unknown number is x. That's our pronumeral. And we have a couple of operations happening here. We have a little multiply in between. And this, because fraction problems are just divide problems, we have a divide. So a times and a divide. So let's start by drawing up our little table just to help us remember which steps to do first. So if we knew what x was, the first thing we would do to it is times it by 2. And then after that we would divide by 6. So that's if we're building our equation or working it out. But we're solving, so to solve our equation we're going to go in the reverse order and do the opposite operations, or the inverses. So the opposite, or the inverse of divided by 6, or the opposite of divide is times, so we'll times by 6 instead. And then the opposite of timesing by 2 is dividing by 2. So we're going to be timesing by 6 and then dividing by 2 to solve our equation. So just like last time, I'm going to show my working out in a different colour because that just helps me understand what's going on. So we need to do the same to both sides. So the first thing we're doing is timesing by 6. So I'm going to multiply the left-hand side by 6 and the right-hand side by 6. Let's do the easy one first. So on the right-hand side, if I go 4 multiplied by 6, well, that gives us 24. If I have a look at the left-hand side, well, I've got divided by 6 here, and then a times by 6 here. Because they're opposites, they're really, if they're both there, they're not having any effect. They're undoing each other. So I can just pretty much rewrite that side, but without the divide by 6. So all that's left is 2x. Okay, so we've done these two. Now we have to divide by 2. So let's divide both sides by 2. We always have to do the same to both sides, otherwise our equation won't be balanced. They won't have the same value on each side. So I like to do the easy ones first. So 24 divided by 2, so half of 24 will give us 12. And well, we've got a times by 2 here, and then we've got divide by 2. And because they're opposites, well, that 2 is just going to disappear. There's no point doing both because they're undoing each other. So all that's left is just x by itself, and that's what we're after. So because both sides of the equation have to have the same value, we can safely say that x is 12. And we can go back and check that just like last time in green, because I like green. We can get x, or 12 in this case, we can get 12 and we can place it back into the original equation. So let's do that really quickly. So I'll just rewrite it 2 times, we have to put times because they're not a number and a letter next to each other, 2 times 12 divided by 6 equals 4. So we're not doing BODMAS in reverse, we're just doing normal BODMAS now. So 2 times 12 gives us 24 on the top of the fraction, we still have 6 down the bottom, and it still equals 4. So 24 divided by 6, well, you can fit 6 in to 24 4 times. So that definitely, this side equals 4, and this side equals 4. So we're all good. So because we substituted 12 back into the equation, and both sides ended up having the same value, we know that all of our working out is correct.